Okay, this is for section 6-7, and this is the last section out of this chapter. Okay, this is on solving radical equations. Yeah, and inequalities. Okay, first, when they talk about a radical equation has variables in the radicand. That means underneath the radical symbol, there's going to be a variable. Okay, and two key things. Okay, one is you isolate the radical. That means you get the radical by itself on one side of the equal sign. If there's more than one radical, then you may have to do that twice. Okay, so you isolate the radical. Okay, and the critical part is you check for extraneous roots. You have to check your answers on these problems. Okay? Because you're going to square both sides, and when you square both sides or cube both sides of an equal sign, you introduce what they call extraneous roots. They're roots to the new equation, but not roots to the original. So this is a must. You have to check your answers back in the original. Okay? Okay, so we're going to go through some, and all I will say is just solve. These will be equations and inequalities. Okay, I'll take you through a couple of each. Okay, so if they give you, as an example, the square root of y minus 2, and then minus 1 equals 5. Okay, and that's what they mean by a radical equation. There's a variable underneath the radicand, okay, or in that radical. Okay, so first thing you want to do is get this radical by itself. So add 1 to both sides. Isolate the radical, get that radical by itself. And then if it's a square root, to get rid of that radical, square both sides. If it would be a cube root, you'd cube both sides. So all that's going to do is get rid of that radical. Okay? So you'd have y minus 2 equals 36. Add 2 to both sides, and y equals 38. Okay? Now you have to check both sides. You have to check it. So you got to substitute this back in the original. Okay? So you actually need to write out your check. So square root, you have to write this out. Okay? And then you'd have the square root of 36 minus 1. And when they're considering the square root of 36, they're considering the principal nth root. So they're saying that's 6 minus 1. So 5 equals 5. Yeah, that checks. So y equals 38 is the solution. Okay? But you have to check it. Okay? Let's try another one.
So if it doesn't check, then...
Like if it didn't check, then you'll say no solution. Yep. There will actually be somewhere you'll end up with 2 possible answers, and one checks and one doesn't. Okay? I will tell you, this is primetime ACT question. Okay? Because like if I worked a problem and I said the answers were 3 and negative 2. Okay? And then one of them checks and one of them doesn't. So on the multiple choice, I'd give you 3 and negative 2. I'd give you 3. I'd give you negative 2, and I'd give you no solution. And they're going to find out if you took time to check your answers. Yep. So the critical part is you have to check your answers. Okay. Okay. Let's say I have the square root of x minus 12 equals 2 minus radical x. Okay, there's two radicals. So one of them is already by itself. Okay, so you don't have to isolate. This one's already by itself, so you're going to square both sides. Okay, now the part where you have to be careful is when you have a binomial squared. I'll go back and review. If you have a binomial squared, the long way to do that is to multiply a plus b times a plus b, FOIL that out, a squared plus ab plus ab plus b squared. This is the long way. You get a squared plus 2ab plus b squared. Shortcut is square the first one. So if you square that, a squared, multiply these two together, ab, and double it, 2ab, and then square the last one. So the most common error is people say that answer is a squared plus b squared. They leave out the middle term. If you square a binomial, you should always get a trinomial square. You always get 3 terms. Okay? Okay, so go back to this. If I square this, it's just going to get the x minus 12. Shortcut to square this, you square the first term, 4. You multiply these two together, negative 2 radical x, and double it, negative 4 radical x, and then square the last term, it's x. Okay? So you always get a trinomial square. Okay, now you have to isolate the radical. So get this. So get the 4 over, bring this x over. Right, the x's drop out. You get negative 16 equals negative 4 radical x. Okay with that? Divide by negative 4. 4 equals the square root of x. Square both sides. Square both sides, you get 16 equals x. Okay? Now you got to check it. Okay, when you check it back in the original. So you go all the way back to 16 minus 12 equals 2 minus radical 16. So 16 minus 12 should be 4. 2 minus 4, so you get 2 equals negative 2. No, so it does not check. So there is no solution. That means 16 is what they call an extraneous root. 16 is a solution to this equation, but it is not a solution to the original. Okay, so every time you square both sides, cube both sides, you have to check your answer. So our final answer on that one is no solution. Okay. Okay, third example. This one's an inequality. Okay, so they give you the square root of 3x minus 6 plus 4 is less than or equal to 7. One part of this on the inequalities with radicals is that they're considering these to be real. So if those are real, that means you cannot have a square root of a negative. Okay, so little note out here to the side. Remember, the radicand, that's the part underneath the radical, the radicand must be greater than or equal to 0. Okay, we're not considering any I values on these. Okay, so take the part that's underneath the radical, the 3x minus 6, and make it greater than or equal to 0. and solve that much. So you get x is greater than or equal to 2. That's going to be part of our answer. Okay? You're always going to look at that radical. Okay? Now take
Why
the...
did you have 6 on the left side?
Because it's not greater than 0.
Are we okay? Okay. Now solve this part. Subtract 4. Just like you would. And remember, the only difference is if you multiply or divide by a negative, you have to reverse the arrow. Okay, so we've got the square root of 3x minus 6 is less than or equal to 3. Now get rid of the radical. Square both sides. So we'd have 3x minus 6 is less than or equal to 9. Add 6. So 3x is less than or equal to 15. So x is less than or equal to 5. Okay? So now, put both parts together in a combined inequality. You put the x, the variable, goes in the middle. Okay? So x is less than or equal to 5, and x is greater than or equal to... The arrows have to point in the same direction. Okay? So you have x is less than or equal to 5 and greater than or equal to 2. And that's your final answer. Okay? Okay? Everybody okay with that one? Okay, last example.
So you only have to do the other part.
Inequality, if it's an inequality.
So you have to
Because that part underneath the radical, this part can't be negative. We're not considering I values. Yep. Okay. Okay, last example. Say they give you a 3y plus 1 to the 1/3 power plus 5 equals 0. 1/3 power, same as what radical? Cube root. So this is 3y plus 1. The cube root of that plus 5 equals 0. Isolate the radical. So subtract 5 on both sides. So cube root of 3y plus 1 equals negative 5. Get rid of the cube root. Cube both sides. So all that's going to do is get rid of that radical. So you'd have 3y plus 1. Negative 5 times negative 5.
125.
Yep, so times a negative 5. Negative 125. Okay, and then subtract 1 on both sides. So I get 3y equals a negative 126. Divide by 3. Y equals a negative 42. Okay, now you have to check your answers. Okay, so go back and check. So if we checked it, we'd have, go back to 3 times a negative 42 plus 5 equals 0. So 3 times a negative 42 is a negative 120. Wait a minute, I wrote something wrong. I didn't put the plus 1 in there. Sorry, that's my fault. Plus 1 to the 1/3 plus 5 equals 0. That's my fault. So that'd be a negative 126 plus 1. So that'd be a negative 125 to the 1/3. So that's like the cube root of a negative 125. So that'd be a negative 5 plus 5. Yep. So it checks. So final answer is negative 42. Okay? So you have to check your answers. Okay? Okay. That should get you started.